We're journeying to the Red Planet to explore a truly colossal wonder, Olympus Mons. This isn't just a mountain, it's a volcano of epic proportions, the largest one in our entire solar system. Imagine Mount Everest nearly 3 times taller. That's Olympus Mons. Its base is massive, stretching as wide as the entire state of Arizona. Olympus Mons is so large, it dwarfs anything we have on Earth. It's a shield volcano, formed by lava flows over eons. Mars has weaker gravity than Earth, allowing volcanoes to grow much taller. This means Olympus Mons sat over its volcanic hotspot for millions, even billions of years, growing larger with every eruption. The James Webb Telescope is a game-changer for astronomy. It sees the universe in infrared light, letting it peer through dust and gas, revealing secrets hidden from ordinary telescopes. When it comes to Olympus Mons, the James Webb Telescope is like a heat-seeking eye in the sky. It can detect subtle temperature variations on the volcano's surface, hinting at what lies beneath. Imagine seeing the faint heat signatures of ancient lava flows, or detecting differences in mineral composition across the volcano's vast slopes. This data allows scientists to piece together the history of Olympus Mons like never before. The James Webb Telescope's observations have implications far beyond understanding a single volcano. They offer clues about Mars' past habitability, potential resources for future missions, and even the possibility of finding evidence of past life. Before the James Webb Telescope, our understanding of Olympus Mons came from orbiting spacecraft and rovers on the surface. These missions provided incredible images and data, but the James Webb Telescope adds a whole new dimension. The James Webb Telescope's infrared vision cuts through the thin Martian atmosphere, revealing the volcano's heat signature with incredible precision. This allows scientists to identify different types of volcanic rock, each with its unique temperature signature. They suggest that Olympus Mons was active for a surprisingly long time, perhaps billions of years. Some areas show signs of relatively recent eruptions, geologically speaking, maybe just a few million years ago. Olympus Mons stands as a testament to this turbulent history, a monument built by countless eruptions over eons. But the James Webb Telescope's observations go beyond just dating the volcano. They provide clues about how Olympus Mons erupted and how its lava flowed, shaping the surrounding landscape. The way lava cools and solidifies creates distinct patterns, like wrinkles on a giant's face. The James Webb Telescope can see these patterns in exquisite detail, helping scientists understand the viscosity of the lava, the speed of the flows, and even the direction of ancient eruptions. These insights are crucial for understanding not just Olympus Mons, but the entire geological history of Mars. By studying Olympus Mons, we're peeling back layers of time, uncovering secrets about Mars's past and its evolution into the planet we see today. Picture this. Billions of years ago, Mars was a much more active place, volcanically speaking. Deep beneath the surface, molten rock, known as magma, churned and surged, seeking a way out. In a region we now call the Tharsis Rise, a plume of this superheated magma rose from the planet's interior, like a blowtorch aimed at the Martian crust. This marked the birth of Olympus Mons. It formed as a shield volcano, built not by violent eruptions, but by a slow, steady outpouring of lava. Over millions of years, these lava flows spread out, cooled and solidified, layer upon layer. Each eruption added to the volcano's height and width, slowly building it into the behemoth we see today. One of the key factors in Olympus Mons' colossal size is Mars's relatively weak gravity. Compared to Earth, Mars has only about 38% of the surface gravity. This means that structures on Mars, including mountains and volcanoes, don't have to fight as hard against gravity's pull. On Earth, the weight of the blocks limits how high you can build before the tower collapses under its own weight. But on Mars, with its weaker gravity, you could build the same tower much taller before reaching its stability limit. The lava flows that built Olympus Mons didn't spread out as much as they would have on Earth. Instead, they piled up around the volcanic vent, creating the volcano's distinctive shallow slopes and massive profile. On Earth, the planet's crust is broken into a patchwork of tectonic plates that constantly shift and move. These plates can collide, separate, or slide past each other, leading to earthquakes, mountain building, and volcanic activity. But Mars is different. While there's evidence of ancient tectonic activity, the planet's surface is now considered to be largely inactive. This means that once a volcano forms on Mars, it stays put, sitting over its volcanic hotspot for millions or even billions of years. For eons, the volcano remained fixed over its magma source, allowing lava to erupt from the same spot time and time again. Each eruption added to the volcano's already impressive bulk, slowly building it into the giant we see today. Olympus Mons isn't just a big volcano, it's a time capsule. Each layer of rock, from its base to its summit, holds clues about Mars's geological past. The James Webb Telescope's observations, combined with data from previous missions, allow scientists to study the composition of these rocks in detail. By identifying the minerals present, they can estimate when the rocks formed, the temperatures at which they cooled, and even the presence of water or other volatile compounds. The layers of Olympus Mons record a much longer history, spanning millions or even billions of years. By studying these layers, we're not just learning about a single volcano, we're gaining insights into the evolution of an entire planet. The sheer size and age of Olympus Mons tell us that Mars was once a much more geologically active place than it is today. The fact that such a massive volcano could form suggests that Mars's interior was much hotter in the past, driving intense volcanic activity. This volcanic activity wasn't limited to Olympus Mons. It shaped the entire Martian surface. Vast plains of volcanic rock, towering mountains, and canyons carved by lava flows all point to a planet where volcanoes played a dominant role. As Mars cooled over billions of years, its volcanic activity waned. Olympus Mons stands as a monument to this bygone era, a reminder of a time when the red planet was a hotbed of volcanic fury. Volcanoes are like giant chimneys, spewing out gases from a planet's interior. On early Mars, these volcanic gases, including water vapor, carbon dioxide, and sulfur dioxide, would have played a crucial role in shaping the planet's atmosphere. The massive eruptions that built Olympus Mons would have released enormous quantities of these gases into the Martian sky. These gases could have created a thicker, warmer atmosphere, potentially allowing liquid water to exist on the surface, a key ingredient for life as we know it. However, over time, Mars lost much of its early atmosphere to space. Despite this loss, the legacy of Mars's volcanic past is still imprinted in its thin atmosphere today. Now, you might be thinking, Olympus Mons is impressive, but what does it mean for us? Why does it matter? Well, as we venture further into our cosmic backyard, places like Olympus Mons become more than just scientific curiosities. They become potential destinations, resources, and even clues in our search for life beyond Earth. Imagine this: future astronauts, boots on Martian soil, gazing up at the towering slopes of Olympus Mons. It would be a sight unlike anything on Earth, a testament to the incredible forces that shaped our solar system. For one thing, its massive size and stable structure make it a potential landing site for future missions. Imagine setting up a base camp on the flanks of this giant volcano, shielded from some of the harsh Martian radiation by the mountain itself. Remember, Olympus Mons was built by lava flows over billions of years. As these flows cooled and solidified on the surface, they often created underground channels called lava tubes. These tubes, some potentially large enough to drive a rover through, could offer shelter from the harsh Martian environment, providing stable temperatures and protection from radiation. Lava tubes could also be havens for potential resources. Water ice, essential for future human missions, might be trapped within these underground caverns, shielded from the sun's rays. And minerals, deposited by volcanic processes, could be valuable for construction or even life support systems. By combining the James Webb Telescope data with information from orbiting spacecraft and future rovers equipped with ground-penetrating radar, we can build a detailed picture of what lies beneath the surface of Olympus Mons, revealing potential resources and safe havens for future explorers. And perhaps, just perhaps, Olympus Mons holds clues to the biggest question of all. Was there ever life on Mars? While the surface of Mars is a harsh, unforgiving place today, with intense radiation and a thin, dry atmosphere, conditions beneath the surface, particularly within those lava tubes, might be more hospitable. If life ever existed on Mars, it might have retreated underground as the planet's surface became less habitable. These lava tubes, with their stable temperatures, potential water sources, and protection from radiation, could be havens for microbial life clinging to existence in the Martian underground. While the James Webb Telescope can't directly detect life, its observations, combined with data from future missions, can help us identify the most promising locations to search. Olympus Mons, with its long history and potential for harboring subsurface environments, is a prime target in this search for life beyond Earth. Olympus Mons, this colossal volcano, stands as a silent testament to the powerful forces that have shaped our solar system. It's a beacon in the vastness of space, a reminder that even on a seemingly barren planet like Mars, nature can create wonders of breathtaking scale and beauty. For centuries, we could only gaze at this Martian giant from afar, our telescopes revealing tantalizing glimpses of its immense size, but leaving us yearning for a closer look. Now, thanks to the James Webb Telescope, we're finally able to peer beneath the surface, to unravel the secrets hidden within its ancient rocks and lava flows. The James Webb Telescope's infrared vision has given us a new perspective on this familiar landmark, revealing details about its composition, history, and potential that were unimaginable just a few years ago. Olympus Mons, with its towering presence and hidden depths, is a treasure trove of scientific discovery waiting to be explored. As we look to the future of space exploration, Mars beckons with the promise of adventure and discovery. Olympus Mons will be a site of intense interest, where science fiction could become reality. Imagine astronauts trekking across Mars, aiming for the summit of Olympus Mons. The view from the top would be unlike anything ever witnessed by human eyes. Olympus Mons could play a vital role in sustaining a human presence on Mars. Its lava tubes could offer shelter from the harsh Martian environment. These caverns could become homes, research stations, and mining outposts. Water ice could be used for drinking, growing crops, or creating rocket fuel. Minerals could be used for construction or to manufacture tools. Olympus Mons could become a cornerstone of our future on the Red Planet. The story of Olympus Mons is a testament to human curiosity and our drive to explore the unknown. From the first blurry images captured by early telescopes to the detailed observations of the James Webb Telescope, our understanding of this Martian giant has grown, pushing the boundaries of science and technology. But this journey is far from over. As we continue to explore, we're bound to uncover more wonders. So the next time you gaze up at the night sky, let your eyes wander to that faint red dot. Keep looking up and never lose your sense of wonder.